you can develop. Then finally, the algorithm will be stored inside the ECU, which is a small computer. Who is going to write the code? The algorithm will be converted into C or C++ or Python code by a computer science. Please note that it not necessarily only computer science engineers should write software. Only the electron ECU hardware can be developed by only electronic person. The PID algorithm or fuzzy logic can be developed by control system. You can do, but only thing you have to learn all these things. You should know how to write C program, how to debug, all those things you have to learn. Then PID algorithm means you have to study control system course and develop this one. And hardware means how to develop PCB, all those things, circuit, all those things you can learn. But it is not compulsory. But at least you should know that what is ECU hardware content, what is microcontroller, what is ADC, what is DAC, 8-bit microcontroller, 16-bit microcontroller, what it means, clock speed, all those things you should understand. That's why you are doing this course. Right? We are going to talk about it. If the electronic engineer who is going to help you in your team, because it's a team management. It is a mechatronic product cannot be made individually. Individual means just an electrical engineer alone, just a computer science alone, or somebody control engineer, or a mechanical man. You can make machine. You have the knowledge how to build. As a mechanical engineer, you know how to design an engine. What are component? You fabricate this and force, all this thing, combustion, all this thing you know. So you develop an engine. Engine was developed by you, but now it's a fuel injection. That means the ECU should be developed. And control algorithm, ECU is only like a computer which is going to execute the program. The program algorithm, control algorithm develop, and finally C will be written. That's how it works. So this figure shows what are the different type of this one combination. Mechanical engineer develop a mechanical system, and electrical engineer develop a motor. Correct? You have a washing machine, for example, simple washing machine, very crude as washing machine. You cannot do many things achieve what is a modern washing machine. So if you talk about washing machine, later I'm going to say it has a drum which will be filled with water, in which you put your cloth. The drum will be rotated by an electrical motor. Correct? A drum will be there, correct, with the enclosure. Bottom you have a motor. Motor is an electrical engineering job. This motor should be controlled from your power supply. Correct? With a kind of electronic circuit which will supply necessary voltage, V motor. So I motor current is going. So the motor start rotating. Omega. Correct? Angular velocity is going to maybe make the drum to rotate clockwise and also counterclockwise during agitation, washing cycle. So the drum will rotate. Who is going to motor is going to do? This is a mechanical structure, all these things. So this is simple washing. Who will make this drum? All this only mechanical engineer. The whole washing machine is a mechanical engineer, and only mechanical engineer can decide. But the drum should be rotated at clockwise, anti-clockwise, doing washing cycle, drying cycle. It should be made to rotate in particular clockwise direction. Water pump will be there, small pump. Again, you have to drain. All these things will be electrical circuit. I don't need computer science. I'm not going to big algorithm. I don't need ECU at all. Simple electronic circuit can be made, and the electrical motor to be controlled by an electrical engineer. 2 engineers are sufficient. Mechanical engineer is simple washing machine. Electrical engineer made the what type of motor need, the related control circuit, all these things. So the machine is also it is called electromechanical device. Correct? Instead of that, the mechanical engineer develops something. You need to sense lot of parameters and you need to develop control algorithm, PID algorithm. That means you need to develop control and actuators. Motor is in this example, motor is actuator. I want to measure what is the speed at which motor is rotating. I'll put a speed sensor. So you need these sensors and actuators installed on mechanical system. Of course, is there. That is also actuator which is going to pump water. The motor is going to rotate the drum, in which cloth will be there, agitation will take place. So actuator will be there. Under the control engine, you can implement simple control. That means I need an ECU on which I write a control component. So it becomes the control plus. If I have pure just rotate this one, I am having a complex control implementing. Instead of that, the same machine can be controlled with a ECU, correct? Digital computer, then computer software. You should know C, C++, all this thing. Like this. The different combination. If I combine all the engineering knowledge, then you can make mechatronics. That's what it is. Okay. Shall I go to next slide?
Sure, sir. Sure, sir.
Okay. Now we are talking about examples. As I told you, we have variety of examples. Wherever you see, it is a mechatronic system. Because, for example, take a car. Simple car, take Nano. It has an engine. It uses fuel injection. I'm talking all in terms of your field of interest. Okay. You take a Tata or Nano, the simplest car. It costs around 2 lakhs something now. I don't know whether they are able to sell. They started with 1 lakh or 1.2 lakh. Now maybe 2.5 lakh depending on model. This is low cost system, but full system. Correct. I came to know that it has fuel injection system. ECU is there. It has a climate control, AC, all those things can be controlled. Top model. Correct. Climate control is there. Correct. Then ECU. Then steering system is there. And braking also, ABS also. I heard on top model. Really, I don't know whether all these things. So all these things are called as an individual subsystem. Engine is a subsystem, and climate control, AC, compressor, all those things need to be controlled. That is another subsystem. Steering system, then ABS, braking system, ABS, anti-lock braking system. These are more. These are the 4 basic important. Subsystem of a low cost car, which I am talking about Tata Nano, but it has all the features which are luxury, because AC is already luxury, comfortable, you can go. ABS help in stopping your vehicle very in short distance without making roll, all those things, skidding avoids. Then steering control reduces steering time needed by the driver. So these are already available. So that is what is shown here. If you take car, there you have 4 subsystems, each one is controlled, each one is mechanical. Correct. Gearbox, automatic transmission gearbox. Gearbox is made of all gears, lot of clutches, all these things. They are all mechanical. That should be controlled by electronic circuit. You write your program. So it is an example. One subsystem itself is a complex mechatronic system. Correct. Then engine fuel injection is needed. It can be CRDA diesel engine. Petrol engine means port fuel PFI, or it can be GDA. It has engine. Engine has many parts: crankshaft, piston, cylinder head. Correct. All the parts should be made individually. You assemble engine. They come maybe having around the 200, 300 parts in bolts. Not many things are small component. Together, engine is formed. That is pure mechanical. Correct. Only mechanical engine can make the engine. What material you can make it? Aluminium. You can make it cast iron. You can make special material. Depending on weight reduction, strength, more power. It should transfer heat quickly so that it get overheated. So that is a very complex. Then you are going to have the fuel injector, correct? Spark control, correct? And all these things are then to measure engine speed, amount of air went inside the engine, how much fuel should be injected, correct? What is the cam position, so that which time you have to inject the fuel, which time this one should be open, inlet valve. All these things will be done by one electronic control. So engine is again a subsystem electronically controlled. So you will use a simple ECU, powerful ECU, not simple multi-element. You have to use maybe 1632 microcontroller, which acts as a. We'll see that anyway. So brakes, correct? Brake and steering system, air conditioner, correct? Like many active suspension. Please note that whatever is mentioned here consists of one computer, which is called embedded controller or ECU, electronic control unit, in which control algorithms are put and a lot of sensors to control particular subsystem. Okay, in autonomous car, apart from this, you have the vehicle controller. Vehicle controller is a power, another ECU. It needs very powerful computer, maybe 60B. Correct. You may use i5, i7 processor itself. You can build your own. You can use computer. Generally, computer don't use. They use embedded controller using vehicle controller. The vehicle controller is going to control the steering system. It is going to control the engine. It is going to control the braking system. Correct. It may control. Correct. These 3 things are controlled by vehicle controller. Correct. We'll see the course is about that only. Computer controlling the engine, brakes, steering system based on input system, how the driver is driving. That's what the whole course we are going to. Correct. When we talk about introduction to autonomous. Because some of you, correct, the previous batch have done this course, new batch will be doing which is called introduction to autonomous vehicle. We will talk separately about controlling the vehicle, but this vehicle itself is a mechatronics, correct? This course, today course, we are not going to do what we are this semester. When you come to IAV, the controlling autonomous car, which by controlling engine, brakes, all these things itself is a separate course, which is called as driverless car, self-driving car, autonomous vehicle. Very complex mechatronic system. but we are not going to talk detail. That we'll talk when you study about IAV. The previous batch 2023 batch will already studied. 24 batch will study next semester or something like that. Okay, fine. Then I give another example is in controlling the aircraft. Correct? We call autopilot. Autopilot. You know that when aircraft takes off from the runway, it has to reach because each aircraft should fly at particular height. That is mentioned by the ATC, air traffic controller. You can see that in any airport there will be a tower, a tall tower on which top of that there will be a small room, 360-degree window, glass window. There will be the people will be sitting and doing it. They are the ATC controllers, correct? From there they can see any plane landing. They can see the entire airport because there will be generally put a height of 50 meters, 60 meter, 100-meter height. This room, the ATC will be a room, tall structure in the airport. You can see generally near the main airport. This one will be there. So they will see which aircraft is landing, which aircraft will take off. All those things. They give instruction to pilot. Once the aircraft comes within radius, control radius, but that depending upon the airport or radar size, all those things, it can be 100. The pilot is controlling aircraft based on the ATC controller. Each aircraft will be controlled one operator. In ATC room, which is there, there may be some 20, 30 ATC controller who will give direction, what speed the plane should go, what height it has to maintain, how they're doing using radar. Then your aircraft is always monitored. Once the vehicle comes, this is my airport, radius. Correct? This is my airport, this one, maybe 200 kilometers, Chennai airport. Any aircraft cutting within surrounding is monitored by a powerful radar. So each aircraft is given a number, that is specific number that is not given to you, and the ATC controller knows. He will talk to the pilot by giving the number. Like police know they call us using number like that. The number will do. So he will say that maintain this altitude. Aircrafts are maintained by height. For example, from Earth surface, maybe generally 30,000, 35,000 feet. I am talking about 30,000 feet.